the topic of my discussion is about digital twins and more around, making it practical. So let me jump in. Right. So I think, when I was preparing for the discussion, I think one of the things that came up, digital twin, I'm not sure how well known the term is. I think there's a lot of confusion around, what is meant with this. A lot of people focus on, 3D modeling of a mine when they talk about digital twin, etc. So I thought I'd do a bit of research around, what different definitions are and how different companies and organizations feel about what a digital twin is. I've highlighted some of those there. So, from mining companies like Anglo, to technology providers like IBM and, research businesses like Gartner. So you can see a different, set of definitions there for what a digital twin is in the general context, not necessarily in the mining context. But you'll see there in blue, there's sort of a golden thread throughout this around what a digital twin really is. I mean, if I highlight a few of those things, a digital representation of a real world entity, virtual models of a technical process, virtual model designed to accurately reflect physical object, virtual model of a process, product, or service, or a virtual replica of a physical asset. So you can see there's this sort of similarity in those definitions around what a digital twin is. The one that we sort of like the most is the one here from IBM, which is that a digital twin is a virtual representation of an object or system, and I think more importantly, a system that spans its life cycle, right? It's updated from real-time data and uses, technology and solutions like simulation, machine learning, reasoning, etc., to help decision making. But I think that's the most important part for especially from an AVA perspective, is to help decision making. That's the whole point of a digital twin. Right. So for us, let me just quickly do that. So why? So the question really is, why should, if that's the definition of a digital twin, why should this be, a topic of discussion or something that a mine really looks at? So, linking back to the previous definition, it's really about creating visibility for improved control and increased productivity. Ultimately, the only reason why you would invest in creating a digital twin is, to improve control, to have visibility of what's happening in real time and increase productivity, whether that be reducing cost, whether that means, generating more tons with the same sort of assets, whatever productivity would mean in each situation for each mine. But that's really for us the purpose of why to do this. If you look at what other companies have said in terms of the benefits of a digital twin, Rio Tinto, which I think very often are sort of at the head of leaders in terms of technology and that sort of space, they say that they can better interact and use the data that they gather, and it gives them access to real-time data in the field to support operators and maintainers. And I really like that as well as a definition or as a benefit of digital twin, because if it's so often, I think companies, solution providers, etc., see systems and digital twins and digitization as a silver bullet, which it's not, right? It's only an enabler. It's still people that are going to make the decisions, still people that are going to implement solutions, just simply using good data, from a system. That's the key. But it's not really about, just having a system. Having a system doesn't solve your problems. In fact, very often it even causes more. So that's really the key. I like that definition or benefit that they've mentioned there. And then Exxaro, in a huge coal mining business here, especially in South Africa, what they've said is that it enables them to analyze data and monitor systems, and it gives them real-time data from pit to port for enhanced productivity and safety, as well as a competitive edge, which is also an important point. A digital twin or digitalization can be a competitive edge. If you have real-time information, have visibility of what's going on your operation, obviously decisions can be made better, which means, being more competitive. I think another important point on that sort of definition or benefit statement is that it's from pit to port. So the definition from IBM, it was about having visibility or creating a model of the entire value chain or the entire life cycle. So I think that's really the key. Okay. Right. So having said that, given that a digital twin is a virtual representation of the mining value chain, right, that is updated from real-time data to help decision making. That's sort of how I see, if you look at those definitions, those benefit statements, that's, I think, how it fits within the mining space. But now the question is, how do you create that without increasing complexity and costs? I've been through many different demonstrations and demos and things from really large consulting companies around digitization, and I think so many people are on this bandwagon. Everything from planning systems, production management, fleet management, all of this stuff. People are talking about digitization, integrating all of that stuff, and it's really great and it's fantastic. But I think the trick is how, right? It seems on paper, it seems it's possible and easy, but it's really not. So, and you have legacy systems, all of that stuff. You have mines that are really mature from a technology point of view, others that are not that mature. So it's really not that simple. So how do you do this, right? If there's benefit, if you see as a company that there's benefit, how do you go about creating this digital twin across the mining value chain? So our perspective or our view is that you start in pieces. So, just trying to digitize the entire value chain, as one large project is not really going to be that successful or very, very difficult and costly. So I think the idea is you start in pieces, and you would realistically, in our opinion, the place to start is around production and the transport part of the value chain, just simply because the largest portion of costs reside in that sort of portion of the value chain. So if you can do some digitization work, some digital twin work, around production and transport, you should see a lot of benefit in that space first, and then obviously, increase the scope of your digital twin, whether it be, backwards in terms of the planning phase, or forwards within, shipping, blending, etc. So that's the sort of idea or suggestion from our point of view, is start where there's the most benefit, and start small, right, and build towards it. Right. So going down this journey of creating a digital twin, I think there's a few building blocks that are important to make it successful, but more importantly, also simple and cost effective. Because again, you can go really crazy, spend a lot of money and get very, very little value. So I think these are the 5 sort of key building blocks that would, should enable you to create a digital twin, piece by piece, but still at a cost-effective sort of, in a cost-effective way. So if I'm starting there from the top right, I think one of the key things is that, utilizing off-the-shelf and cost-effective hardware. So, technologies have come a long way with, whether it be with, communication infrastructure, as well as, GIS type of technology, etc. So, utilizing hardware that already exists off the shelf instead of trying to reinvent the wheel is really a key building block. Then utilizing existing communication infrastructure. So as I mentioned, 3G, 4G, 5G has really enabled a lot around digital twin and digitization in mining. So utilizing that communication infrastructure, it shouldn't be necessary for a mine to have to invest in really expensive private LTE or Wi-Fi, etc. If we can leverage those existing infrastructure systems like LTE and like 5G, 4G, 3G, etc. Then whatever data is created to generate this digital twin, should be gathered automatically. So minimize user input. For a few reasons. Mainly, it creates more simple solution, and secondly, it makes increases data quality. Not relying on people to input data is really the key. And obviously, if you're moving towards a digitization strategy or a digital twin, that's the whole point, is to try and eliminate the need for manual data input. Then leverage cloud computing technology. So again, the days of when each solution needed an on-site server, the costs, the maintenance, everything involved in that is no longer necessary. So I think leveraging that will reduce cost and as well as complexity. And then very importantly, I think when it comes to creating a digital twin will generate a lot of information, a lot of data, but it's about packaging that data and structuring it correctly so that you can use it, right? So whether it be, data lakes, data warehouses, doing some really good transformations and wrangling, etc. on that data is, I think, the key, so that you can use it and easily create, dashboards, reports, etc., and use the data and analyze the data. Right. So if we focus then on creating a digital twin around sort of production and transport phase of a mine, there's a few things sorry, there we go. What sort of attributes should that model have or that digital twin have, right? So I think for every mine, it might be slightly different, but I really thought about it. And in general, I think, most surface mining operations, irrespective, I think the region or the commodity would have similar needs in terms of creating a digital twin. So I tried to classify those attributes or those areas in which you would want a digital twin. So I essentially see this as the components or the pieces of that digital twin. So if I start from the top there, I think a few things would be really valuable and important to be able to make better decisions. So I think having a view of your assets, whether those are mobile assets or fixed assets, that is a really, really important part of it. Secondly, asset analysis. So whether that means condition monitoring or just idling and engine hours, etc. So just having a visibility, any telemetry sort of data. So asset analysis, so that is specifically looking at each individual asset, all the IoT stuff, etc. within the asset analysis space. So that's, I think, very high level on the asset space where, what you would want to see with a digital twin. If you think more about the process, I think a digital twin should generate or create or provide an exhaustive time model. So, every single activity or event that is performed on the mine should be part of that time model so that you have a full view of every single 24 hours on the mine. I think, and really, remember, I'm talking specifically around production and transport, that sort of phase within the mining value chain. Production data, I mean, that's pretty self-explanatory and really, really important to have, availability of that information or visibility of that information in real time. Then production cycle analysis. So whether that is queuing time, filling time, dumping times, travel times, etc. I think that's really, really key in terms of a digital twin. Delay event analysis. So, I mean, the other half of that coin is really delay. So whether production cycles as well as delays, and being able to analyze those. And then I think the final component is really around the people side. So again, it's people that are operating these machines. It's people working on the mine. So creating visibility of what operators are doing, what how people are performing, etc. I think is a really, really important component to creating a digital twin for a surface operation. Right. So I'm not going to read through all of these, but I'll highlight maybe just a few. If you had to break down those 6-7 components on the right-hand side and just maybe create or highlight some of the key, I want to call it KPIs, but these KPIs or data points or metrics that you would want to see as part of a digital twin so that you can make better decisions. I've listed some of those there. So on the left-hand side, it's really all around the BCMs, tonnage, cycle times, etc. That middle section is all around the delays, utilization, availability, things like the basic, telemetry and condition monitoring information like engine hours and idling times, etc. Maintenance events. And then on the right-hand side, maybe a little bit more on the safety and security, operator performance, compliance to plan. So those are the types of things that you could fit into one of those blocks on the right, around creating a digital twin. It's really a digital twin in our definition, when you talk about production transport, is really just a model of what's happening there and how well that phase in a value chain is performing. Okay, and these KPIs should enable you, and these are just examples, should enable you to then have that model of that mining value chain step. Right. Just some case studies, maybe from our perspective, where a digital twin, and again, not across the entire value chain, but really focusing on the production and logistics part of the mining value chain, where it has created benefit. So Exxaro, which I quoted as one of those benefit statements, they have a coal mine here in South Africa, and they've created a digital twin of just their load and haul operations. They have 3 mining contractors on site, and the mining contractors are simply just doing the overburden removal or production. And after creating a digital twin, they've increased their production by 33%, which is obviously it's a huge number from the previous year to the next year. So just by having visibility, some of the examples, there's a few YouTube videos about this, but there's a few ways in which they did this. Just simply having visibility of what's going on, enable them to identify where the bottlenecks are. And then also from an operator point of view, they actually use the digital twin to incentivize their operators better, financially as well. So having visibility of what can be done, what should be done, creating targets, incentivizing those targets, also led to creating or increasing productivity by 33%. So that's a really, really good case study of where it's worked. Similarly, a smaller aggregate producer, again here in South Africa, they've reduced costs. Although that doesn't sound like a large number in the context of this operation, that's a fairly large number. The $70,000 a year in terms of cost reduction. Increasing the hammer operating hours, increasing hammer overall efficiency, and then I think from a safety perspective, this is a really important one: reducing overspeeding events. So something as simple as that, knowing and having visibility of overspeeding events and being able to monitor and police those, has had a huge impact on your risk, right, around safety events or health and safety events. And then finally, a coal mine, again, here in South Africa, they've reduced their cycle delays by 25%, and that's increased production by 7%. So again, just having visibility and having that model that they can have a look at in real time. Right. How much time is so? That's pretty much it from my perspective.
We have Adityo Burhanuddin Hakim. Adityo is with PT Bukit Asam, the state-owned coal miner here. How accurate is the predictions of the digitalization in mining, in targeting the amount of production, monthly production, or for a period of time to accomplish target in transportation to port, maintaining, sorry, I guess it would be, with the aim to minimize the potential of having demurrage on the vessels. Does that make sense?
Yeah, sure. So I think the prediction, I think it's very difficult for me to say. I can't really tell you how, a digital twin, there's no one-stop shop, one solution, that you can just go and implement. It's very difficult for me to say how accurate are the predictions. It depends on so many different factors. What are you using? What sort of data is being created or provided into, whether it be machine learning algorithm or different simulation models or whatever. So I think it depends on so many factors. Very, very difficult for me to say how accurate are predictions.
Okay. Yeah, okay. So you mentioned it's really not that simple. Are you seeing hesitance? In Indonesia, I would assume, it's going to take a while to really penetrate the market. But, for example, other big miners around the world, has there been been any hesitance from them to adopt this?
To be honest, no. I think it's a really great time to be in this sort of space. I think a lot of mining companies are really moving towards this. For me, I think the keys, and I don't know if that came across as strong as I would have wanted to, but I think, when people think about digitization or digital twin, immediately they expect, or the perception is that, it's really complicated, really, really, really difficult and expensive. And it shouldn't be. Very often that's what people sell is this really, really complicated stuff, but it shouldn't be. If I take some examples, let's say in Peru, so we're busy with three people there, three big mining contractors there, and for them it's just about getting people out of the pit. People standing there with tally sheets, with a clipboard, a piece of paper, counting loads.
Right.
Just having real-time visibility of where the assets are, instead of having, and production data, those delays. I spoke to yesterday, we had a discussion with a mine in the States, and you would expect, okay, well, it's the States, so much technology, etc. Same sort of thing. They have a manual system where they capture delays and capture production data. So it's just about digitizing that. That's the first step. So, if you're thinking about, I was part of a presentation at one of the really, really big consulting firms, which globally they're one of the biggest. And they've got fantastic models and fantastic, presentations, and a whole room where they have a digital mine and all of that. And that's great. But my first question to them was, okay, but where do you get the data for this? And they really couldn't answer the question because it's too much. You can't automate the whole thing or create an entire digital twin. It's about baby steps, and I think a lot of mines are happy to do that now,
Right.
and at least take a few steps forward.
There we have from Mansour Risk Management at Peter Mahenwa. Jonathan, I think for the data you put in your slides, such as tonnage, total cycle time, truck filling time, truck time, empty, hanging time, etc. That's all already recorded in the electronic modules of Caterpillar and Komatsu. Something that's more impactful is how can we monitor any operation information about premature damage or undercarriage? Can you use artificial intelligence to ascertain that?
So I think it's a great comment, actually, because I think when you look at the slides, immediately you think a lot of what I've said is just fleet management, and that's true. It's actually really true. Fleet management, whether it be a modular, whether it be AVA, whether it be whatever it is, right? It's just in our view just a means towards a digital twin. It's covering a piece of creating a digital twin. So a lot of that stuff is, mines will already have it, but there are a lot of mines that have none of that.
Right.
And if they have it, it's manual, or it's very, very inaccurate and very delayed. It takes them a few days to get that data. So in terms of the second part of the question, what else can we do, whether it be, using machine learning, using whatever algorithms, using, I think there's so many options. Very difficult to answer. What can we do? For us, if you talk about AVA, that's not our space, right? But there's a lot of guys out there that do that type of stuff. What you can do, yes, then that's a really, really, many things, so many things you can do, and tools that you can use to create a digital twin. And I'm probably not the best equipped to answer, because that's not our space, right? Our space is, moving towards digital twin, integrating with other solutions that are already, working, and where mines have nothing, they can use our system to take a few steps forward. I'm sorry I'm not giving the best answer. I wish I could answer it a little bit better, the second half of that question, but that's probably my best attempt.
So basically, you're kind of agglomerating off-the-shelf technologies into a single process.
That's the idea, right? So we like to use what's available already. So, no mine wants to go and replace the systems that they have, or, and so rather what we would do is, there's a few things. One is integrations. So integrating with whatever is on site already, that's a key one. And then especially on the data analytics side, is saying, well, what do you have? You have these, pockets of data. How do you put that together and create a better, holistic view of what's happening on the mine? That's the sort of space that we're in, and where I think there's greater opportunity and more value, rather than trying to sell more and more and more and more systems to mines, and each one telling the mine that they're the expert, they're the best, and then ultimately those systems are normally just focused on certain areas. So you get maintenance systems, you get fleet management, you get these types of systems, but they don't always talk to one another. Right. So I think that's the value, and most mines have something. So again, you don't want to have to go and replace everything. Use what's there to create that digital twin.
Great. And Adrian Geiler didn't say where he's from, but I know Adrian's from Fluid Tech. Can this system be used for fixed plant processes as well as mobile fleets?
Okay, so if we talk about AVA itself, so what we do is not necessarily in the plant side. So we've sort of ring fenced it, everything from drill and blast, up to where it goes into the plant. I think where there might be an opportunity, if you talk again, I don't want to just talk about what we do, what AVA does, but that's more on the integration side, whether it be then PLCs or other software, that's SCADA systems, etc., used in the plant space. But that's not what we do. But again, PLCs or SCADA systems, or systems around the plant area, again, is another piece that can be used to create a digital twin of that mining operation.
Okay. I have a question, or just a comment actually, before we head out here. We're running a bit behind. Indonesia, obviously telecommunications are a big issue. Talking standing on the top of the mountain, in the tree trying to get a signal. Maybe in a follow-up, you could address, if you have poor communications, how would this be integrated? But that is for a different time. I apologize, we're out of time. But thanks, very interesting presentation. And again, thank you very much for sponsoring and being a part of today's event.
No, thank you very much for the opportunity. Thanks for the questions as well.
Okay. Thanks, Jonathan.